Covenant Christian High School's annual egg launch. Let's talk about the paper you're supposed to write. It's good to cite your sources, and we're using our textbook, Physics the First Course. And so there's the full MLA style of documenting that, and I recommend parenthetical citation at the end of the sentence. So you're supposed to write several paragraphs about the physics of the egg launch and how does this physics concept apply to the egg launch. So first off, what happened was we took your container up to the top of the building, and we converted that, we gave it some more gravitational potential energy. And that gravitational potential energy was actually increased a little bit more when it was launched at an angle from a water balloon launcher. So pulling back that surgical tubing of the water balloon launcher gave it elastic potential energy. In your paper, you don't have to have the equations, but K being the spring constant, X being the distance it was pulled back. So the elastic potential energy is converted into energy of motion called?
Kinetic energy.
Kinetic energy, that is correct.
Oh, yes.
You can read more about that on page 68 in your textbook. So, by the conservation of mechanical energy is defined as the sum total of the potential plus the kinetic. At first, we might say that it has no kinetic energy. That's true, since it's just sitting there in the egg launcher. And then it's released, and it has all of this, it's released from the elastic potential energy, gets converted into kinetic energy. Next off is now a projectile. What is a projectile? A projectile is something where the only force acting on it is the force of gravity. So you want to talk about the independent nature of the vertical and the horizontal motion and how they are independent of one another. Vertically, there's that force of gravity. So we have the acceleration of gravity because F equals ma. If you have a force, you're going to have an acceleration. So because of that acceleration, we can use the acceleration equation like this nice little guy right here. And horizontally, what's going on? Well, we're going to assume for the sake of our equations that there's no force that is going at a constant velocity. Therefore, we can use the definition of velocity. Velocity is defined as distance over time. We're going to use this, solve for the distance, in order to find that the range, also known as the distance in the x direction. However, it does not actually go that far. It doesn't go the 200, 300, 400 meters because of how lightweight your object is. Objects that are light and fast are affected by air more than ones that are massive and not so fast. It depends upon the mass, the size, shape, and the velocity of your object. Well, it also depends upon the density of the medium. So it will not go the projected distance, and reflect upon your object, upon your container. Is yours really heavy or was yours lightweight? And then is that going to be more or less resistance? So you could say, mine was heavy, so it was less affected by air resistance. My calculations came out better. And finally, your container hit the ground, sometimes with hilarious effect. And what you want to write about is this thing called the impulse momentum theorem. Impulse is defined as the force times that change in distance. So if an object, if there's a force applied over a period of time or for a period of time, then there's an impulse. It will cause it to change its momentum. Momentum is defined as the product of mass and velocity. You really want to write about the collision, the impact, and how you wanted to increase your time of impact by creating some padding and some things like that so as to decrease your force.